Ganesan sir.
Hello.
Sir, good morning.
Chandras, are you able to see me?
Sir, actually I am Santosh. Sir, Ganesan sir. Hello.
Yes.
Sir, Santosh.
Santosh, I am Ganeshan. Are you able to
Yes
hear
sir,
me?
yes sir. Sir, shall we start, sir?
Hello.
Sir, shall we start the program?
Are you able to hear me?
Yes sir, I can able to hear you, sir. Sir, shall we start the session, sir? Sir, whether my voice is audible to you, sir?
Hello.
Sir, can you hear my voice?
Hello, I am hearing you.
Yes sir. Can we start the program, sir?
Can we proceed today's session?
Yes sir, of course, sir. Definitely.
Good morning, friends. In continuation with yesterday, we are going to discuss about the geometric product specifications. So, what you are going to learn out of today's workshop? We know that geometric dimensional drawings are used in industries extensively in the recent times because to ensure the product manufacturing to the functional requirement. At the same time, we try to reduce the cost and the rejection of the parts, as well as we ensure the functionality of the assembly. So what you are going to get out of this class? You are able to understand the soft floor drawing by knowing the notations and symbols used in the geometric dimensioning and tolerancing. And you are able to manufacture the component in the shop floor using the GD&T principles. Then you are able to inspect the component using the proper tools as per the GD&T requirement. In addition to that, you are able to create the drawing with the geometric dimensioning and tolerancing symbols. So all these design department, manufacturing department, inspection departments are connected through the GD&T standardization. So this standardization comes from the ASME 14.5M. It is a standard used for geometric dimensioning and tolerancing. So it is accepted throughout the world, but there is a equivalent ISO version is available. 11,000, sorry, 1101. So 1101 is the ISO specification for ASME 14.5M. So this is started in the year 1940 during the World War time. Over the period, it is find the importance and it is converted into a standard which is acceptable throughout the world. So why the GD&T has to be used? So yesterday we have discussed about there are different type of tolerances are there in the
Morning. Good morning. Please sit down.
industry.
Welcome to your.
They are come under the three important category. One is called a general tolerance. Any component which is manufactured with a certain amount of tolerance, but it is not specifically specified in the drawing, but it is given in the title block. I will show the example how it will look like. So in the title block, certain amount of information is given. What is the tolerance applicable for the size as well as for the inclination or angle? That tolerance we call it as general tolerance. Then another tolerance we call it as linear tolerances. So the size can be varied plus or minus or plus certain value or minus certain value Those tolerances are, we call it as linear tolerances. Then the third category, but which we are specifically discussing, is geometric tolerances, which are concerned with the feature of form, profile, or location, not its size or dimension. So it is applicable to the shape of the product, location of the product. These are the two aspects the geometric tolerance is concerned. Because the another tolerance, the linear tolerance and the general tolerance, are concerned about the dimension, or you can say about its sizes. So geometric dimensioning and tolerancing, GDT supports the function of the part in the assembly. That's the main importance, because many of the cases the assembly is not able to perform as intended by the designer. The reason is the GDT is not properly assigned. We will see how it is going to be important at a later point. So already I said the GDT allows variation for the form, orientation, and location. So what are the those form, what are the orientation, what are the location, what are the profile, all these things we will see later point. So it is the uh, specification define the feature more accurately. It permits the same amount of size and tolerance as usual. So size tolerance is not affected by the geometric tolerance. So geometric tolerance is one portion and the size tolerance is another portion, but within the size tolerance, the tolerance, geometric tolerance is specified. So we know that we have windows in our houses, factories, in buildings for air circulation. So the window frame, you can see it is a rectangular or in square in shape. So it is fixed during the construction period. And after the construction is over, then finally the window panel, or we can call it as window doors, are installed. So during the installation, you may notice the carpenter will do some type of adjustment in the door frame comes, or the window door frame comes. So to make it the exact fitting of the door frame and the door or window frame and the windows. Why he has to do? Both are manufactured to a particular size, which is already specified as a standard. Now you can see here the standard, the height is 6 feet 6 inch, and the width is 2 feet, 2.4 feet, 2.8 feet. So 6 inch, 6 feet 8 inch. Width is 2 feet 8 inch. So these are the standard. So as per the standard only the door frame is manufactured, and also the door also manufactured. But still, why the carpenter has to fit it correctly by removing certain amount of material in different poses. So that is not followed the geometric tolerances accurately. That is the reason how that is affecting, and we will see it later. So this is another example. Now you can see this drawing dimension given. The whole dimension is 25.1 mm maximum size, and 25.0 is the minimum size for the whole. So the MMC is 25 and LMC is 25.1. What does it mean by LMC and MMC? So here I specified MMC means maximum material condition, LMC means least material condition. The part will have a maximum material. Suppose this is the hole in a object, it will have a maximum material when its size is 25.1 or 25.0. So material is maximum, the weight also maximum. So when the hole is smaller, the material is maximum. Are you able to understand? So the 25 mm provides a maximum material condition for the hole, and the 25.1 mm produce least material. That is, the more material is removed, 0.1 mm additional material is removed. That means it has a least material. So a tolerance will have two limits. One specifies the maximum material, another one is specifying the minimum material. For the hole, minimum material is the smallest hole. Maximum material is the smallest hole. Least material is the largest hole. The same way for the external feature, the 25 mm is the maximum material condition and the 24.9 is the minimum material condition. So this is also have two limits. One is the maximum limit and the minimum limit. This is the minimum limit, is the maximum limit. So LMC and SMC. So when we are giving dimensions like this in the drawing, we will have a manufactured component will be like this, because we are verifying the diameter is within the limit of 25.1 mm to 25.0 mm. So within the limit, the component is produced. So the component will have a size tolerance throughout its length will be within the limit, but it may have a slightly inclined hole. Similarly, the hole may be a tapered one like this. The hole may be a tapered one like this. So here the minimum size is 25, maximum size is 25.1. Within the size only the component is manufactured, but it will have a possibility to produce like this or like this. Both these components are accepted in the inspection, because as per the dimension, both are satisfying the
Participants, sorry for the issue. I think the SOR is having the technical issue.
hello.
Sir. Sir.
Sorry, someday again the system was struck. I don't know.
Okay,
I think
okay.
the file is larger in size, so they are hanging.
Okay, sir.
I'll do it again. I will open it.
Okay, sir. Participant, be patient. Wait for few seconds. The SOR will again join the meet.
One minute, please. It is system is opening. Because the file I think larger in size, so it is.
Okay, sir. No issue, sir.
Hello, 1 minute. Hello. Dear students, are you able to hear me?
Sir, tell me, sir. Sir, Santosh.
Are
Sir,
you able to
but
see the-
your PPT is not visible to us because you have shared the screen only, sir.
Hello.
Hello, are you able to see the slideshow?
No, sir. We can't able to see the slide, sir.
So now?
Yes, sir. It is visible, sir.
Yes, I'll do it. I'll connect.
Visible, sir.
Right. So when we are manufacturing the component with the dimensions given as per the size, we are getting the component like this. When we try to assemble, now you can see the internal part and external part I am given it here. But when it is both are placed side by side, you can observe there is a problem in the assembly. So now you can see here there is a top part. Which is in this direction. But for this component, it will be like this. So now you can see here the top. It is the hole is smaller in the top side and larger in the bottom side. But in this case, it will be in the opposite direction. But it may be a rare case. Randomly, if you are assembling, the assembly cannot be possible for around 30 to 40% of the components. So not all the components are get rejected. Only certain amount of components are get rejected. Even though it is a value-added product, but it is get rejected because the tolerance given by the size has a limitation. So now you can see here the limitation of size tolerance. A part can be produced. The external part, a shaft can be produced like this, a bound one or a counter shaft, or it may be a vested. The center portion will have a smaller diameter, but the edge portion will have a larger diameter, or it is a barreled like this. End portions are smaller in size, but the center will be larger in size. And this will be a tapered one. Now you can see here the red line shows the maximum material condition and the blue line shows the minimum material conditions. So within the limit only all these components are manufactured. But due to the form which is created, which is not controlled by the manufacturing process, as per the size tolerance, all these parts are manufactured and come for assembly. So when we try to assemble these parts, then automatically assembly problem will come. Even the assembly is okay, the functionality will not be there. Suppose for if it is a journal bar, I am going to show a
வரவே இல்லை. தண்ணி அதே மாதிரி சூடா இல்ல தண்ணி சேர்த்து.
Hello. Hello.
Participant.
Hello, dear
Sorry for
participants.
the-
Hello.
Sir, you inform, sir. What is it?
Hello.
Sir,
Tell me.
Sir will log in within 5 minutes, sir. Just you inform to participants.
Okay. Dear participants of this workshop, please be patient. Sir will be logging within 5 minutes.
Okay, sir.
Thank you.
Due to some network issue, we can't
Yeah.
able to visible the
Connect.
PPT. So be
Okay.
patient, participants.
Now,
Ganeshan, sir.
now, I'm sorry.
Sir, it is visible, sir. Visible, sir.
Okay, now,
Sir, you can able to start, sir.
now you can see here an example of journal bearing. If you have a cylindrical shaft at the center, there is a cap at the circumference. So this rod has to be straight as well as it has to be circular. And this has to be cylindrical in nature. A cylinder The hollow cylinder will hold a solid cylinder. Then only the lubrication is uniform throughout the circumference of the solid cylinder. So now you can see here in the cross section, this is the journal and this is the collar. In between there is a small gap at the gap or clearance which has to be uniform throughout the length. Then only the lubrication is supplied uniformly. Then we are getting the proper operation. Hello? Are you able to see, understand the importance of the geometric tolerances? It must be cylindrical. Then only we are able to supply a uniform lubrication throughout the length. So the wear and tear will be uniform. So the functional requirement of the journal bearing is obtained with the help of the geometric dimensioning. Now you can see in another example, this is a spool valve, or you can see a directional control valve. Now you can see here it is a 4-way valve. One side the pressurized fluid will enter, another side the fluid will be returned back to the exhaust. So this entry and this is the exhaust. So one position this will be the case. Another case it is moved to this side, that time this will be exhaust and this will be the pressure. So that's the way you can see the diagram. So when you can see here there is a cylindrical portion at the center and there is a another cylinder which are attached and it is moving inside a hollow cylinder. So this rod to be straight and this to be cylindrical in nature, or you can say it is a circular, and this hollow portion also a cylinder. So when then only you can able to lock the fluid on one part and avoid the fluid to enter into the other part. So the proper alignment between the internal part and the external part ensures the proper movement of the fluid. So a very minute clearance will be there. Because of that one, the fluid will be passing from one side to another side. So this should be straight and it should be cylindrical in nature. The cylindricity is ensured not by the size tolerance, it is only ensured by the geometric tolerances. Then only the functionality of the spool valve is ensured. Are you able to understand here? Now there is another example. Now you can see here a table we want to manufacture. So you can see here it is a wooden table. The top surface is flat and 4 legs are equal length. So the dimensions of the table is, the height is given as 27 inch plus or minus 1 inch. That is the standard specified in the drawing. This we call it as size tolerance. So as per the size tolerance, we can manufacture the component. After that, within the limit of 26 inch and 28 inch, the component is manufactured. So it may have a 26 inch size or 27 inch size or 28 inch size or in between 26 and 28. Any size comes will be acceptable. But now you can see the top surface which is wavy in nature. So it will pass through the inspection as per the size or height requirement. Now you can see a table which has a tapered at the top, which also within the limit of 26 inch and 28 inch. This table also pass the inspection. But usage wise, either the table will have a wavy at the top, you cannot place the flat surface of the object over the table. Or you can see here this type of taper, that also not acceptable. But as per the size tolerance, these two tables are passing the inspection. So what we have to do, this type of size tolerance has a limitation that only we can able to understand. So the same table can be manufactured with a flatness tolerance with 0.06 inch at the top. So the size tolerance is there. In addition to that, we are adding a geometric tolerance. Both are come hand by hand. Because of that one, we are able to manufacture a component like this. So this is the 27 inches nominal size with the top surface which have a waviness which is fall within the limit of 0.06 inch. Now you can see there is a two perfect plane. Oh, inside that two perfect plane of separated 0.06 inch. Inside that one, the actual top surface will fall. So this a small amount of waviness will allow the part to function properly. Or you can see here the 28-inch height, maximum height with the
Hello. Hello. Santosh? Hello.
Sir, tell me, sir.
Again, technical issues, huh?
Yes, sir.
Okay, okay. Have you spoke with sir?
No, no,
Have you
sir.
spoke with sir?
Shiva
Okay.
called to sir.
Okay, okay. Good.
Participants, sorry for the inconvenience because sorry of the technical issue, network issue. That's what the problem. So please be patient. Wait for 5 to 10 minutes.
Hello?
Sir.
Sorry, I'm coming back.
Okay, okay, sir. Okay, sir. No issues, sir.
So now you can see here the table has to be manufactured with the geometric dimensioning and tolerancing, so that every table which is manufactured will be get accepted, and also it perform the required function properly. So we can able to understand how the GDT will help us to make the assembly to be possible, and also the assembly will function, or the part will function as per the requirement. So both the functionality and reduction of the rejection is possible with the help of geometric tolerancing. Because of that one, we are getting an advantage of uh, improvement of the functionality, reduction of the cost, and the standard procedure which is adapted throughout the world, because the component manufactured at the different locations, different factory, different industries, different part of the world can be assembled successfully with the help of standardization of the geometric dimensioning and tolerancing. So these are the three important aspects we gain from the uh, geometric dimensioning and tolerancing. So there is another limitation with the coordinate tolerancing or size tolerancing is, when we are locating a hole in the space, the hole has to be located in x direction and y direction. When we are locating the x direction and y direction, both have certain amount of tolerance, we get a tolerance zone of square in shape. Suppose you can see here, in this case, the size is varying from 9.75 mm to 10.25 mm with the tolerance of 0.5 mm, get a square tolerance zone. So x direction and y direction, the tolerance value is only 0.5 mm. In x direction, if you are taking 0.5 mm is the tolerance. Y direction also 0.5 direction. But in the xy direction or in the diagonal direction, the tolerance value is increased to a value of 0.707 mm. That means in one particular direction, the tolerance is maximum, but another directions, the tolerance is minimum. So not uniform distribution of the tolerance value in the space. So this can be converted into a circular tolerance zone. That time we get additional tolerance. That is an advantage for the geometric tolerancing. So now you have another limitations. The size tolerance is not specifying what way we have to inspect. Suppose it is a surface plate and it is an angle plate, through in over that one, we are placing the component in two different orientations. Now you can see in the x direction, the two hole distance can be measured. The second hole distance can be measured, or in the vertical direction. When we are orienting at a two different way, there is a error in the inspection. One person is placing in horizontal direction, one person is placing in the vertical direction. There is a ambiguous inspection for the inspector. So because of that, one error will come. One person say the component is acceptable, but another person check it and say it is not acceptable. So there is a inspection error will come into picture. So both the manufacturing wise, the design wise, function wise, and inspection wise, geometric dimensioning and tolerancing will not have any limitation, but coordinate dimensioning or size tolerancing has their limitations. So because of that only we are come for the GDT. So GDT is used in the design area, tooling area, production area, and inspection area. Already we have seen design, manufacturing. Manufacturing is related to the tooling and production, and the inspection. All these three places, the GDT is important. It is not only important inside the factory, it also connected with the outside, to the customer, to the supply chain management, to the purchasing department, sales department, service department, everywhere it is also connected outside the factory. So there also a problem that also has to be taken into account by using the GDT. So GDT domain importance are in the factory, outside the factory. These are the two areas. So what are the way we can get it, the GDT to be get used? To define the nominal geometry of the parts and assemblies, to define the allowable variation in the form and the possible size of individual feature, then to define the allowable variation between the features. All these locations, the GDT has to be used to make it a precision component. So it has already, I told you, it is started in 1940, during World War time, and over the period, it get acceptance throughout the world, and it is standardization also taken place. The standardization comes from the ASME, American Society of Manufacturing Engineers Association. From that one, it is accepted to other area. Now ISO standard also available. So after ISO 9000, it is mandatory to use the standard for producing the component. Then when to use the GDT, when part features are critical to function or interchangeability is important, and the functional gauging is desirable. When datum reference are desirable to ensure consistency between the design. So one person is designing and another person also design, there is a consistency in the design that is ensured by GDT usage. The standard interpretation of the tolerance by all the inspectors. And it is allows a better choice of machining process because it allows more tolerance zone compared to square or rectangular tolerance zone. It uses a circular tolerance zone that will add the additional tolerance area. So automatically cost will be get reduced by having a better choice of machining process. So advantages: saving money, ensuring dimensional tolerance, required assistance digital design methods, because digital design is the latest area in which everybody is trying to give the digital information from one department to another department. The information is easily conveyed throughout the world by in the digital form. So GDT supports the digital manufacturing. Then offering uniformity and convenience, and providing accurate communication between the different manufacturing people and the customer, other people. So some of the important terms which we have to use it are feature, feature of size, feature of tolerance frame, datum, feature characteristic symbol. I'm slightly going fast. The reason is we find it lesser time. Actually, I'm giving only the introduction, but actually the application part has to be extended beyond this session. So now you can see the any component, you can identify the different parts of a component as a feature. So now you can see here the part will have a fillet, then top edge, the hole, then 3D surface, outer surface, edge. So like that, all the component or portion of the component are identified as a feature. Then what is a feature of size? If any feature is bounded by a boundary of cylindrical or spherical nature or parallel planes, that we call it as feature of size. Now you can see part width is here bounded by two parallel surfaces. So it is here feature of size. The hole, it is a cylindrical nature, that hole is a feature of size. Then part height is bounded by two surface, bottom and the top surface, that also feature of a size. So these are the terms which are important for GDT representation. So limit of size, which is equal to tolerance, we already know the size of a component will vary from minimum material condition to maximum material condition. Now you can see here for a SAT, the red line shows the maximum material condition and the blue line shows the minimum material condition, and in between the nominal size is represented with a black line. Now you can see here MMC MMC for a internal feature and a external feature. You can see already in the whole portion, the red line shows the maximum material condition for both hole and the shaft. Now you can easily understand the red line always shows the maximum material condition and blue line shows the minimum material condition. The difference between the red line of the external feature and the internal feature is called allowance. Difference between the blue line shows the maximum clearance. So now you can see the diagram. One larger size shows the LMC and another one shows a smaller size which is MMC for a internal feature or hole. But for external feature, maximum material condition will have the maximum size, minimum size will have the minimum material condition. So material condition symbols in the drawing we can use it. M bounded by a circle is called a maximum material condition. The another one is called a least material condition. The third one is called a regardless of feature size. So what is the meaning of regardless of feature size? When we are measuring a component, whether it is the material is part is having a maximum size or minimum size, it is immaterial. Only the measurement is important or the tolerance is important. That is called a regardless of feature. But the maximum material condition, the inspection has to be done when the material is considered as having maximum in the part or feature. So that is called the maximum material condition. Least material condition means the feature has a lesser amount of material, that time inspection tolerance is applicable. So any deviation from maximum material condition or minimum material condition, additional tolerance are available. But in case of a regardless of feature, no additional tolerance will come into picture, whether it is a larger in size or smaller in size, only variation given in the drawing alone is applicable. Then free state condition, that is bounded by F, bounded by a circle. That means some of the part, for example, a spring without tolerance value, because the normally spring is to a certain amount of load. So that time the tolerance will vary or the material property will vary. So that we call it as free state condition. So the tolerance is applicable to free state condition. Then projected tolerance. Projected tolerance is a tolerance. Some cases before assembly it will have certain amount of tolerance. After assembly of smaller component or larger component, that meaning will be changing. That is called as projected. So it has a certain amount of tolerance. Whatever the size of the assembly, the tolerance value will not change. That is called the projected tolerance. And tangent plane, only the outer periphery which will touch the tangent line alone will be considered for accounting the geometric tolerance. Then another information is used in the GD&T is feature control frame. It uses the different information in a frame. Now you can see the first frame or first rectangle will have a symbol that we call it as geometric characteristic symbol. It may be having different shape. This particular shape is representing the true position tolerance. Then another one, shape of the tolerance zone. The tolerance zone will have different shape. It may be area between the two parallel planes or line between the area between the two lines, or it is the volume bounded by two circumferential cylinders or concentric cylinders, or it is bounded by two concentric circles. So all these things we will see in the next diagram. Then the value is given as a 0.500 that is individual feature tolerance value. Then M is bounded by that one, that is a feature modifier. Then the remaining things are called the datums. A, B, C are datum. And above the frame, certain informations are there. That is called the size tolerance. Diameter 9 plus or minus 0.25 mm. So that is size tolerance feature. Size tolerance feature and the feature control frames are placed adjacent to each other, or only feature control frame alone is placed in certain cases. So the datum, there are three datum. The first one is primary datum, second one is secondary datum, third one is tertiary datum. So now we try to understand the datum. Datum is a surface or line or a central line or a point from which all measurements are taken. It may be a line, it may be a point, it may be a surface, or it may be a center line. These are the four different cases. It may be a point, it may be a line, it may be a surface, or it may be a center line. Even some cases it may be a central plane. So when we talk about the component, our product is located in the space. The product can move in 12 different ways, that we call it as 12 degrees of freedom. Now you can see a rectangle piece which is placed in the space can able to move x, y, z direction, and it can able to rotate in the x, y and the z direction. So in the both the positive and the negative directions and negative rotational directions, totally we have 12 different way or 12 different direction a part can move in the space. That we call it as 12 degrees of freedom. But in the manufacturing or inspection, these 12 degrees of freedom has to be arrested. Now you can see here a part is placed in the space which is bound by three datum. One is at the bottom, 90 degree to the bottom, there is a secondary datum. There is another 90 degree to both the primary datum and the secondary datum, that is called a tertiary datum. So primary datum, secondary datum and a tertiary datum. So why one is called a primary datum, another one is called a secondary datum? The first one, which is perfect in form, is considered, and that surface is taken as a primary datum. With respect to, we place the secondary datum, which is 90 degree to the primary datum. Then the tertiary datum, which is 90 degree to both the primary datum and the secondary datum, that is referenced as a third datum. So all these three datums are used as a reference, and the part is located in the space, and it is arrested as per the requirement. Now you can see here the arrow, that is there is a arresting in the primary datum. There are three pins are needed, or three locations has to be identified. For the secondary datum, two locations to be identified. Tertiary datum, one location. Total there are 6 pins or 6 locations are used to arrest 12 degrees of freedom. But still the part is able to move in the minus x direction and minus z direction. That can be arrested by clamping. So datum is very important to represent the component during the machining as well as during the inspection. So already I told you, primary datum is a datum which provides functional relationship for all other things. It is easily accessible, and it can be repeatedly used to get the same information, and it is easy to it is larger in size compared to the other datums. That datum is selected as a primary datum. The primary datum is selected to provide functional relationship, accessibility and repeatability. Now you can see that the bottom surface is the primary datum, which is constrained with the 3 locations, 3 circles are there. Now you can see here the secondary datum, which is 90 degree to the primary datum. Now you can see here in the previous slide, This primary datum is able to arrest 6 degrees of freedom. There are 12 degrees of freedom for a part in a space, but 6 degrees of freedom can be arrested with the help of a primary datum. Additional 4 degrees of freedom, total 10 degrees of freedom can be arrested with the help of the primary datum and secondary datum. Primary datum and the secondary datums are inclined 90 degree to each other. Then there is a third datum which is called territory datum, which is able to arrest all the 12 degrees of freedom. Even this type of datum also very important for the design of tools, design of jigs and fixtures. So here normally we call it as 3-2-1 principle. So 6 pins are 6 locators are used to arrest 12 degrees of freedom. When we are using all the 3 datums, 12 degrees of freedoms can be arrested. Then you can see in the drawing, the datums are represented in the future control frame, and it also specified on the surface as per the ANSI 1982, it is represented as A, 2 dashes on both the sides. In ASME 1994, it is represented by a equilateral triangle, and A is placed in a box. But in the ISO, it is not the equilateral triangle, but slightly a wider triangle is used. So what are the letter can be used for representing the title, datum? The letter A to Z can be used, but normally they will avoid the letters I, O, Q, because it can be used for other purpose or make confusion. To avoid that one, I, O, Q are not used. Sometimes A, B, B, C, C, like that also the datum are represented. Datum in the drawing is represented using symbols shown in the diagram. So now you can see here how the datums are placed in the drawing. In the earlier day, ANSI, American National Standards Institution, 1982, it is represented like this. But in 1994, ASME represented like this. Then recent time it can be represented in the future of size also. So this is the placement of datum. This way also you can using the leader line also you can able to use the locate the datum. Then another one is a datum target. So not the entire surface is used as a datum because surface is very large. Suppose you take a floor, if you want to measure the floor is flat or not entire surface can be measured using an instrument. On certain area at different locations we can able to measure the level, then we come to a conclusion that it may be a flat or it may be a vertical or inclined, etc., etc. So instead of using the total surface as a datum, we use only certain regions for the measurement purpose as a datum. That time, that certain region is called a datum target. So now you can see here the datum target may be on the part or side of the part. So now you can see that into mark is placed inside. That means the datum is located inside the component. But if it is at the edges, means it is represented by a double pin. So now you can see a fixed setup and over a double pin, the part is placed and the measurement is taken. So this way datum target is used. How it is represented? It be represented by B1, B2, A1, A2, and also what is the area at which you are taking the datum consideration? Dia 500 mm. Sorry, dia 0.500. That means it is a 0.5 inch is the size. The datum feature, sometime the datum can be represented like this. That time it has a size tolerance. Because of the size tolerance or feature control size, the future control size will make it a surface like this. So this time it is not a perfect surface, but it is actual surface. Actually, we have a theoretical plan which is straight in nature, but actual surface is wavy in nature. So sometimes unfinished surface also considers a datum. That means the surface which is considered a reference also will have the tolerance value or variation. So some of the cases size datum, when we are representing the size datum like this, it will have a meaning of enclosure like this. So this one will first one will be the size which is specified by diameter, that is enclosed by maximum material condition. That is called the envelope, or we call it as size datum. This is for a external part. This is for the second one is for the internal part. But when we are measuring or when we are inspecting the component using a coordinate measuring machine, that time locating the datum is not difficult, because the surface plate is considered as a primary datum, and there are two other plates that we call it as datum reference frame. Using these three, we able to represent all the three datum, or we are able to inspect the component over the coordinate measuring machine, or we call it as CMM. So CMM will make it the process very simple. So these are the certain geometric characteristics controls. That means geometric characteristics tolerances are listed. There are 14 different geometric characteristics controls. Then what are the meaning? The first one is the flatness, second one is the straightness, third one is the eccentricity, the fourth one is the circularity. So these four are come under the category of form, and they are not related to any other external feature. Flat means that surface is considered as a flat without reference of anything else. Straight means a line is straight, it refers itself. Cylindericity, it refers itself. Circularity, it refers itself. So circularity meaning means the surface points are equally displaced from its axis. Equally displaced from the axis. So it refers only its axis. So it is equal distance from the center. That means it is not referring any external feature. Axis cannot be a feature, but outer surface is a feature. Straightness is a feature, but it is not referred with anything else. So the surface itself referred itself. That type of symbol or geometric characteristics, we call it as form characteristics. Then another three are called the orientation characteristics: perpendicular, inclined, parallel. So we have a floor and there is a wall. So wall is perpendicular to the floor, so that is we call it as perpendicularity. Then parallel, the roof and the floor are parallel to each other. The window frame on both the sides are parallel to each other. Then angularity, sometimes we have an inclined roof, we create that we call it as inclined angularity. So there is a reference is there. With respect to floor, the wall is vertical. With respect to floor, the ground floor and the top floor are parallel to each other. One is referred with the other. Angularity with respect to roof, the inclined wall we can able to say, or the steps we normally placed in a steps in inclined form. So with respect to ground, the steps are inclined. The bottom surface of the steps are inclined in nature. Then position with respect to one part, how the other part is located, that is called the position. Then profile, it is a curved surface or it is a curved line, that is called the profile of a surface, profile of a plane. that is located, but at that time also we are not using any type of reference. With respect to its own location, it is referred. Then we have runout, circular runout and the total runout. Circular runout means a circle is measured with a dial gauge. So when it is rotated, the circle, what is the deviation takes place in the dial gauge? We say it is a circle, but when we are measuring it with a dial gauge, when we are rotating the object, how the dial gauge reading varies on one particular cross section, that is called a circular runout. But if it is for the entire width of the component, then that is called a total runout. Then concentricity, you know that when we are manufacturing a shaft of different diameter in a lathe, we cannot manufacture in a single setup. One side we will machine it, then we rotate the job and put it in the other side, then we will measure it. That time we call it as the axis has to be varied within the certain limit, that we call it as concentric. One diameter concentric with the other diameter. Then symmetry, with respect to one surface, another surface is very similar or not. How much the surface is symmetrical with respect to each other. Suppose in a wall, we put the window at the center, then we can see the symmetrical portion left side and the right side. So that we call it as symmetry. So these are the symbols which are used in the geometric characteristics, which controls a particular tolerance. Then in addition to that, certain amount other symbols also used for the dimensioning to give the proper meaning. I think these are the things already you come across in the machine drawing subject. I'm not going to discuss further. Previously, I told you there are 14 different type of geometric variations. All these variations will have a certain amount of tolerance zone. So now you can see a straightness will have a tolerance zone which is separated by two parallel straight lines. A line will really fall between the two parallel lines which are separated for a distance of tolerance value given. A circle, axial circle will fall between the two concentric circles. Now the third one also a profile of a line, that also between the two parallel line, axial line will fall. Then parallel plane, for flatness, the axial surfaces fall between the two perfectly parallel planes. In that one, the axial plane will fall. Then parallel planes, in a concentric circle, there are two concentric circles, concentric cylinders in which axial cylinder will fall. That is called a cylindricity. Then parallel of planes, the profile of a plane. Then cylindrical tolerance zone for a positional tolerance. So actually the axial component axis will fall inside a cylindrical tolerance zone. Then again parallel planes, then parallel planes for the symmetry and central plane. So these are the different tolerance zones used in the geometric tolerance. I think I'm going to close it with this one. There are two rules are there in the GD&T. With this one, I'm going to close it today's session. The application of the GD&T can be taken as a separate session because it need another 3 hours. So I cannot continue. So with this one, I am going to close it. There are two rules when we are applying a geometric dimensioning and tolerancing. The rule 1 states where only a tolerance of size is specified, the limit of size of individual feature prescribed, the extent to which variation in its form as well as size are allowed. So within the maximum permissible variation or envelope, both the size tolerance and the form tolerance fall inside. That is the meaning. So there is a envelope which shows the maximum material condition. Inside the maximum material condition, both the size tolerance and the form tolerance are come together. So the form tolerance cannot vary beyond the MMC of the material. MMC is the perfect form of the component. That is the meaning of this one. Then another rule, this is the meaning. Now you can see the x-axis 10 plus or minus 1, y-axis 5 plus or minus 1. Inside that boundary, maximum boundary is 6 by 11. Inside that one, both size and form tolerance will fall. Then rule number 2, unless otherwise specified, regardless of material condition has to be taken into account. Regardless of material. Now you can see in the tolerance frame, the first one, RFS, there is no material condition. M or L is not specified, but all other case, M or L is specified. Unless otherwise specified, regardless of feature is the condition we have to consider. I think this is the last slide. So the application of the 14 different tolerances in geometric form has to be discussed as a separate session. Maybe it takes 2 to 3 hours. So with this one, I try to close the session. What I try to convey to you is these things. There are geometric characteristics and their meanings, how the meaning differs from size tolerance. So there is a difference between the coordinate tolerance or size tolerance and geometric tolerance. Size tolerance try to give the variation in the linear direction or in the diametrical direction. But geometric tolerance try to give the variation or permit the variation in the form or shape of the part, location of the part, profile of the part, run out of the part, or position of the part, or tilt of the part. Position, tilt, form, location. So these are the 4 different area, not 4, 5 different area. The geometric tolerances come into picture, but size tolerance come into picture only for the length direction or linear direction. It may be a limit size. Within the limit, the part has to be varied. But the same size, location, profile, and orientation, tilt, all these things are controlled by geometric tolerance. So I think you can able to understand what's the difference between the geometric tolerance and the size tolerance. What the advantage with the size tolerance and the geometric tolerance? Size tolerance is very simple to use it, but it does not ensure the functionality and assembly and the cost reduction. But that is possible in the geometric tolerance. So I think I try to give you an overview about what is the importance of geometric product specifications. So with this one, I close the session. Thank you for the opportunity given by the CSI Engineering College, Ooty. Thank you.
Students, can you hear me? Staffs and professors? Hello?
Yes, sir.
Hello? This is convener of the program. Hello?
Sir, we are. It's audible, sir. Please.
Audible. Okay, okay.
Please go ahead, sir.
On behalf of our CSI management and Department of Mechanical Engineering, on behalf of principal and vice principal, I thank Mr. Professor Ganesan Kalipan sir for his wonderful session. Thank you. Our
I
coordinator.
try to share the PPT.
Okay,
you
sir.
can share it to all.
You can share it, share, sir. Okay, sir.
Okay, thank you. Have a nice day.
Thank you, sir. Thank you, sir. Hello, Mr. Santosh Kumar. Hello.
Sir, sir.
You can give the thanks speech.
Okay, okay.
Hmm.
A very good afternoon to all. It gives me an immense pleasure to deliver the vote of thanks. First of all, I would like to thank our guest and speaker of this event, Dr. Ganesan Kalimuthu, who made this session very interesting and useful. Next of all, I would like to thank our principal, our department HOD, and convener, and the staff members of mechanical department for giving the support to make this event a great successful. Last but not least, I would like to thank our participants from various colleges for your cooperation. Once again, I thank you all for attending this event and taking us a great success. Thank you.
Thank you, sir.
Thank you, sir. Thank you, Ganesan sir. Thank you, Dhanraj sir.
Thank you.
Thank you,
Thank you.
Santosh sir. And thank you, participants. And please do fill the feedback form. And based on filling, we will be generating the e-certificate. If any queries, you can ask us in through WhatsApp group. And thank you. And thank you, Jerry sir, for helping us with the Zoom platform.
So one more thing, participant, if you fill the feedback form, automatically the e-certificate will be generated to you.
Thanks for the coordinators for making this program a great success. Thank you.